Hello my dear champions, I hope all of you are doing really great. So today I'm here in this series of Masterstroke discussing another chapter, two chapters of PU1, which is Introduction to 3D Geometry and Limits and Derivative. Okay, both has a big role to play in PU2 syllabus. This is becoming another chapter only in PU2 3D Geometry. Again, very straightforward formula based approach is there in the Limits and Derivative, and the question of this from the if you see the PYQs of CET are not as many in the last 10 years, but if it comes, it'll be very easy problem. So please go and refer that as well. And limits and derivative, very important. Certainly one question will come. If there's a chance that two questions might also appear, but minimum of one question will come from limits and derivative for sure, and they're going to be very easy. Okay, so let's try to learn the theory part of both these chapters. And for questions, you are following our 15-day challenge. And to solve more questions, if you want to have a better practice, you can refer our crash course of KCET going at a price of 1,999. And if you want to just solve a mock test, you can take our ABHYAS test series going at a price of 999. Okay, so I hope we are ready. Let's start the session right now with this. Let us try to learn the one-shot lecture, the theory lecture of the chapter Introduction to 3D Geometry. Okay, again very simple, not many concept is there in the syllabus. If you see, we have three things. We have to deal with a distance formula. Okay, then we have to deal with your centroid when the three coordinates are given x, y, z, and and the mirror images. That's all. Okay, and we'll look at some questions also. Distance formula, if you talk about, we had more or less the same thing. This is called as 3D space, right? When you have x, y, z coordinate, all three known. Okay, this is the point origin. This is the point, let's say A in this case. So distance formula, we have already seen that for 2D space. For 3D space, just simply add the value of z1 minus z2 the whole square. So basically this point OA, the length will be given by x minus 0, so x square, y minus 0, again y square, and 0 minus, because this is in the plane xy, right? Yeah, this is in the plane xy, so we don't have z coordinate. Okay, so it becomes simply 0. So answer over here comes as OA equals to x square plus y square. This is just an example, guys. This is the concept, the formula, and this is just example how to how to deal with this particular cases. Okay, because in the xy plane we don't have any z axis. Do we have? No, we have. This is going to be behaving like a 2D plane itself, but this one is origin. Okay, we'll have the coordinate as 0, 0, 0. You get the answer as, please check, x square plus y square as the length OA. Okay, so if you talk about this point, let's say, then you have x, y, and z. Let's call this to point B. Then the length will change. If you go from OB, then have this value as x square, y square, and z square. X square, y square, and z square. I hope this is clear. Please check. Yeah? Yes. Moving on. Next is center of a triangle. As I mentioned clearly over there as well, when we're learning about your in 2D space, so everything will remain same. You're simply gonna add the coordinates. How do you find it? This G is basically the intersection of, let's call this to be P, Q, and R. So the AP, BQ, and CR is what are the medians. Okay, so intersection of the medians is going to be the point G, which is called as centroid, and you find the coordinate of centroid as x1, x2, x3 upon 3. What is this, sir? What is this I've written over here? I've written here sigma yi from I equal to 1 to 3 upon 3. What it means is simply take yi as 1, 2, and 3. Add all these values, divided by 3. Okay, sigma yi upon 3 from 1 to 3, and same thing sigma zi upon 3 from 1 to 3. Now, even if you have a case, let's say, if you have a case where in the triangle they have not given you the vertices coordinate, they have given you the coordinates of PQR. Okay, and over here they have given some coordinate x1, y1, x2, y2. I'm not saying they are equal actually. Please don't have that doubt. I'm not saying that this x1 and this x1 is same. Clearly, some different coordinate value they have given. The centroid will again remain same only. So x will be what? x1, x2, x3 by 3. And so we'll have for y also same result, and same ball will for z also. I'll repeat again. So whether they have given the coordinates of the vertices, you use this formula. Coordinates of the centroid, use the same formula. So coordinates of the midpoint, use the same formula to get the result for centroid. Of course, I'm not saying that this x1 is same as this x1. Okay, they are not actually same. Okay, they are just, just showing it. If you use the vertices coordinate and use the formula of centroid, you get the same answer. And if you use the coordinates of the midpoint, if they have given, you'll get the same answer. I'll take a question, I'll explain it as well, okay? So this is the clarity that you need for the centroid of a triangle. Now, distance of a point in a 3D space. So whenever we talk about 3D space, there'll be always a plane. So let's say this P point is in 3D space, which has the coordinate alpha, beta, gamma. The distance of this point P from the plane XY, this is what, sir? XY plane. What is this? XY plane. Then this gamma becomes the distance. Can you see this? If this is a point, let's say Q, then PQ is what? PQ is the distance given as the value gamma. Okay. Now if I talk about the reflection of this point P in the same plane, it simply comes out, alpha beta remains same, only the gamma changes to minus gamma. Okay. Please write that. Only the gamma changes to minus gamma because it's coming down over here. Okay. The other thing remains same only. Alpha, beta, and just minus gamma. If you're talking about the reflection, that's the two type of concept. If you look at the PUIQs over here. Okay. Let's look at some questions. Midpoint of the side of a triangle. Now, this is what I'm talking about. So over here in this triangle, no, they have given the midpoints of the sides. So they have given it this as 1, 5, and minus 1. Over there they've given 0, 4, and minus 2. Over here they've given 2, 3, and 4. 2, 3, and 4. So what they're actually asking you is that if you want to find the centroid of this triangle, can you find that? Yeah, somewhere there will be over here G centroid, which will have the coordinates as x, y, z. If you want to find value of x, you'll get what? 1 plus 0 plus 2 by 3. This comes as, sir, 3 by 3, so 1. Find y. Y is, sir, 5 plus 4 plus 3 by 3. 9 plus 3 is 12, 12 by 3 is 4. Z, sir, z is minus 1, minus 2, and plus 4 by 3. That's 3 and 1, so becomes 1 by 3, sir. So basically my centroid G is coming as 1, 4, and plus 1 by 3. Plus 1 by 3. So I'll write it again because it's not visible. Yeah, 1 second. Yeah. This is coming as 1, 4, and 1 by 3. That's the point G coordinate. That's my option B. So my question is, even if you have, even let's say they had given us the coordinates of ABC, okay, instead of giving the midpoints, if they have given us the coordinates of ABC, the formula will remain same. x1, x2 plus x1 plus x2 plus x3 by 3. Same goes for y and z also. The formula will not change. That's the result. Okay. Next. Distance of the point, this from the xz plane. If you talk about xz plane, let's say, same concept. This is x plane, this is x line, z line. I'm talking about this point, xz. So y coordinate basically, this will be your distance. This will be your distance. So 4 units. Answer is, sir, option A. Okay. Over here, this will be your 4 units, minus 3, 4, and 5 is the point P. Okay, this will be your 4 units. Again, whenever you write distance, even if you had minus 4 over here, take the plus 4 value. Distance is always, you're going to take it as positive only. Okay, so that's more about the concept side of your chapter, Introduction to 3D. Not much is there. I hope you just learn these. More of 3D comes in PU2 syllabus. For PU1, we have limited concepts. I've taken care of that. Section formula is one thing that is there. For section formula, what you do is basically use this result. I just taught you that in the straight line concept. Same result is used in the section formula also. And what is that, sir? Let me just clear that part also. 1 second. Section formula, if I talk about, I don't want to leave that. Section formula. You'll have the same thing. Let's say this is the point A, this is the point B, and P is over here. Now we talk about what? 3 coordinates, x, y, z, and over here, x1, y1, and z1. This is what? x2, y2, and z2. Point P is what? x, y, and z. Then it's same thing. If the ratio is what? m to n. The ratio of AP to PB is m to n. Then how do you find x, sir? Remember, mx2 plus nx1 by m plus n. Over here, for y coordinate, my2 plus ny1 upon m plus n, and for z coordinate, same thing, mz2 plus nz1 upon m plus n. So everything remains same, just that z coordinate part gets added. And if you are looking to find the value, one second, value for external section, this is the case for internal section. So when you talk about the external section, okay, when a is here, b is here, and the point is over here, this is the case for external section. Okay, this is the case of, sorry, external section. External section. Then what happens, bacha? Everything remains same, just that in the formula you'll have minus sign over here. Here minus, here minus, here minus, here minus. Please check. Yeah, same way. Thus I've written the same thing. This is for the always, the yellow one is representing your internal section. Internal section. This is the part 1, and the other one represents your external section, which is the part 2. These two cases are also there. Okay, that's about it when it comes to the formula part and the concept part of the chapter, Introduction to 3D. Okay, so I have covered everything that is there in the syllabus, and which is important for the syllabus. I've solved the questions also. I wish you all the best. If you need to watch the sessions more than once, okay, and cover and get the clarity as much as you need it, you know how to get in touch with me to solve more questions. And that's all for this particular class. We'll see you in the next one. Till then, take care. Bye-bye. So let's start our one-shot lecture for the chapter limits and derivative. So starting with the first thing, which is over here, what is the limit and what is the need of limit? So what happens over here is, for example, in this function, if I ask you to find the function value at 2, okay, you will try to find it, and then you'll reach what? You'll reach that this does not exist, sir. This value does not exist. But if you remember, if we are writing a function like this, we clearly mention that to make this function definable, if we write over here, sir, f of x as x square minus 4 and divide by x minus 2, and alongside this, if I write where x is not equal to 2, then this function becomes defined first of all. Remember, we got to make the denominator of the rational function a non-zero value, right? A non-zero value. So clearly x cannot be equal to 2, right? So if we write this, then function is defined first of all, but still we cannot find the value of the function at 2 because the value at 2 does not exist. Of course, means we are back to the same position. But without using this direct value approach, we can also use the limiting value approach and get the function value at that point. And how do we do that? We do that by basically finding the limiting value, because once x is not equal to 2, it means that I can factorize this now. Have a look. Okay, I can factorize this as x minus 2 and x plus 2 divided by x minus 2. You can clearly see over here that x minus 2 cancels. You have only x plus 2 left. Am I right or not? Yes, sir. So clearly this is possible since x is not equal to 2, bacha, because if you can write here 0 and 0, if somebody says that to you, what if x is equal to 2, sir? Then we'll have 0 and 0, and x plus 2 will cancel 0 and 0. No, this is wrong. We cannot cancel 0 and 0. 0 by 0 is a undefined form. You might have seen a lot of trick maths, okay? Here and there will be people keep coming and asking you this question. 0 by 0 is, sir, 1, because we cancel something. If this method gives me x by x equals to 1, then why can't we carry 0 by 0 as 1? Not possible. 0 by 0 is not defined only, then you cannot cancel that, okay? So whenever you are cancelling anything, whenever you are cancelling x by x as 1, the understanding statement is x should not be 0. That's very, very important. Something is cancelled means that particular value cannot be 0. So once this value is not 0, it means once this is true, then I can cancel these two. And what is my answer? Simply x plus 2. And this is a linear function. This particular value is a linear function. So have a look. Okay. So what can you do about this then, sir? 1 second. Then we can draw the graph of this function, no? X equals to 2, the function will look like what? It's a straight line y equal to x moved up by the value 2. Okay? This is the function. When x is 0, y is 2, sir, and when y is 0, x is minus 2, sir. This is the function. Minus 2 and 2. Okay? But if you talk about this point, so this is the point 4. Sorry, not 4. Excuse me. If you talk about, let's say this is x equals to 2 point. Got it? Then there will be a break in the function. Before this, the function is what? before this the function is x plus 2 and after this also the function is x plus 2. Just at the point 2 the function has a break. Now we can define this function. So the limiting value, if somebody asks you, sir, limiting value of the same function, what is there? X square minus 4 upon x minus 2. Okay, when you approach this value 2 from right hand side, the answer is what? 4. The answer is 4. But this value is how much, sir? This value is 4. Put here 2 value, 2 plus 2 becomes equal to 4. Okay, and if the same reason somebody asks you limiting value of the same function, when you approach 2 from the left hand side, the minus sign on the top of 2 means that you are approaching 2 from left hand side. This means that 2 minus, and when you come from this side it becomes 2 plus. Okay, so when you approach the same function from here, from the left hand side, this value becomes what? Same thing. Okay, so even though you cannot find the function value over here, but you can find the limiting value as 4. Whether you approach from right hand side or left hand side, the limit is what? 4 only. So whenever we say that LH and the RHL are equal, okay, whenever we say LHL value is equal to the RHL value, we call that limit exists. So limiting value of this function, which is both side coming as, because if somebody asks you what is the value right before 4 or right after 4, you cannot go to that value. You can go to 3.999, okay, right before 4, but is it sufficient if I ask you to write a value right before 4? Let's go on this neighborhood and this neighborhood separately. Before 4, if you write here 3.9999 like this, as soon as you stop, I can add another 9 and keep moving on. Okay, means the time you stops, it becomes incorrect. If I say, sir, answer is 3.999, I will come and write one more 9. Is it same? No. I can come write one more 9. So the value before 4 does not exist. So that's why limiting value right before and right after actually will be the same value, 4 only. Okay, because some of you might have this confusion. Sir, at 2 it is 4, right before 2 will be smaller than 4. Correct. What is that value? The value right before 4 and right after 4 does not exist. That is an undefined value. So that limit is taken up to. So even though you are approaching, first of all, whenever I say this, sir, very important. Whenever I say this, sir, x tends to 2, what's the meaning of this one? This has only one meaning, that x is not equal to 2. Whenever you see x tends to 2, the meaning over here is x is not equal to 2. Clear? Okay, but what about this, sir? Sir, x tends to 2 means x is not equal to 2 but close to 2. Understand? X tends to 2 means not equal but close to 2. So same way, limit equals to 4 means not equal to 4 but close to 4. Right, sir? No, false. Limit value is always absolute. Please listen to me very carefully. I'll repeat this statement one more time. Whenever people say x tends to 2, it means that the value of x is not 2 but close to 2 from either side. But the limiting value, if you find at that point, it is always absolute in nature. It is not close to 4. It is always equal to 4. That's why I could say that LH and RHL are equal to 4. It is not 10 to 4. Limit does not tend to 4. Limit at what point is there? That is 10 to 4. Means x tends to 4. X tends to 2. Okay. But the limit value is not like that. I hope this is clear. The fundamentals of limit is clear. Okay. Done, guys? Alright. Now let's move on. Neighborhood of a point. I already explained this to you. Right? When I took the point 2, right after and right before is called as neighborhood of the point. And this is written by 2 plus a small value delta, and over here 2 minus a small value delta. So this interval you see over here, a minus lambda and a plus lambda represents your neighborhood of the point A. And what is this? This is the related neighborhood of the point A. When from the neighborhood, so if I am writing, let's say 2 over here, okay, and this is my, let's say, neighborhood. What is this, sir? This side is plus delta and this side what is minus delta. Okay, then if I denote like this, closed over here, here at 2 open and then here also closed. What it means is, sorry, my bad, such a big mistake. This is not closed now, sir. I cannot have this closed because this is not going to be defined only. Means if I write this interval, not A, right, it is 2 I have taken over here. So 2 minus delta open union, excuse me, sorry, yeah, 2 minus delta 2 minus delta 2 will be there, no? Yeah, to 2 union again 2 to 2 plus delta, means if from the neighborhood of the 2, what is the neighborhood of the 2? Neighborhood of 2 is very clear, sir. Okay, means if you go 2 minus delta from here, this is neighborhood, 2 minus delta to 2 plus delta, this is called as neighborhood of 2, neighborhood of 2. So from the neighborhood of 2, if I ask you right now, in the neighborhood of 2, does 2 present over there? My question again, think about it. In the neighborhood of 2, is the value 2 present over there? Yes, sir, it is present. Now, so if you remove that 2 from that neighborhood, then that becomes deleted neighborhood of the point 2. See, I have taken it out. At both the points, both the intervals, 2 is open. It means 2 is exclusive. So when you remove that point A or remove that point 2 from the neighborhood of that point, that becomes deleted neighborhood of the point. Okay, all right, moving on. Now 10 to condition, again this already explained it to you. Okay, when you go from the right hand side, if you try to tend to the point A from plus side or right hand side, is called as right hand limit, and beforehand means if you go from the left hand side is called as, which is where you're using minus sign. Please check, this was beta your LHL and this is your RHL. So I already took care of both the slides in the previous one only. So I hope still for the revision point of view, notes point of view, this is important, so you can find it over here. Next, algebra of limits. Okay, so very simple, as the formula states, if you have function sum given and limit is outside, you can take limiting value of the functions individually and then take sum or difference. Okay, same goes in the case of product, or in the case of powers, or in the case of quotient, or in the case of inside a function or a rational function, or inside a function, okay, modulus, or limit also function is like this. Getting it? This is combination, no? This is G, F and G. This is a combination of fog. Okay, so limit will apply to the function which is given it to. It can be taken inside and then later apply the function form, but okay. Okay guys, see here, first we find the limit and then we find the GOF. Remains same only, C and L. If limit of the fx at A is, at A is C and at C it is L, then GOF directly becomes equal to what? L. Okay, next, if you have exponential function, you will apply the limit to the function first, then you can take exponent. Same goes in the log also. You will apply to the limit, you will apply limit to the function f first, then you will take what? Log. And what does this bracket mean, beta? Because log cannot work on a negative value. Have you seen log of -2? No, log never operates on a negative domain, right? That's why even you can take the limit on the function fx, but you have to keep the keep that in the mind that limiting value cannot be negative or 0. Log only works on positive values. Evaluation of some standard limits by using the formula form. So one of the very standard one is what? X power n minus a power n upon x minus a is what? N times of a power n minus 1. Please remember these formulas. Okay, yeah. Now evaluation of limits very extensive. So we have 3 methods over here. One is where you use standard limits. We have this one. We have few more. If you want, I can write this. Don't worry, I'm going to give you the formulas later also. Same we have for tan theta also. Yeah, all right. Yeah, so now next is what? When the limit x tends to infinity, then especially in the case of polynomial function taken as rationals, what happens? Okay, so very simple rule is there in this condition. We either remember the trick that I've taught you. What is the trick, if you remember? The trick was that if you have this function ax square plus bx plus c, here we have, let's say, p x square plus qx plus r, and limit is limit x tends to 0. This is always equal to coefficient of x square in numerator by coefficient of x square in denominator. So a by p. Okay. How about if you have over here 0? If degree of numerator is more than degree of denominator, what does it mean, sir? It means that if it is ax cube, yeah, one second, excuse me, this is infinity actually. Ax cube bx square plus cx plus d we have, and over here we have, let's say, px square cx plus qx plus r, excuse me guys. Yes, if you have this form, please check. You will take x square common over here, you will take here x cube common, right? And you'll have still x left in the numerator. Yes or no? You'll have still x left in the numerator, because if you're taking x cube common, you'll have a plus b by x, c by x square, d by x cube. Those terms, if you put x value as infinity, becomes 0, because please check over here, limit of 1 by x power any integral power for limit x tends to infinity is always 0. So check over here, you're getting 1 by x in the b term and c by x square and d by x cube. So when x tends to infinity, this all things becomes equal to 0, and this will be what? Simply there will be 1, no? We have taken x cube common. So but outside we'll have beta, please check. You have taken x square common over here, and over here you've taken what common? X cube common. So you'll cancel x square and x cube. You'll have only one x left, where? In the numerator. If you put the x value as infinity, please check infinity, this value becomes infinity only. If you apply limit x tends to infinity, in this case this value becomes infinity only. Okay, and if it is ulta, if the degree of denominator is more than degree of numerator, it becomes, of course, 0. It becomes 0. So if you have degree of numerator less than degree of denominator, then the limit when x tends to infinity becomes what? 0. This becomes 0. Over here it is, this value is going to be what? Infinity, because you have x left in this case, and in this case if you go, you'll have x or x square, whatever it is, in the denominator, so it becomes 0. Please have a look. This is the case for evaluation of limits when x tends to infinity. Now, a very interesting function, evaluation of limit for a greatest integer function. Think logically. Graphical approach will be helping us to understand this in the best way possible. This is 0, that's 1, this is again 1, 0. So we'll try to understand over here at this point, which is 2. Let's check. If I approach this 2 from this side, which is called as RHL side, yes or no? Means I'm trying to get 2.000000 somewhere 1. Okay, so right after 2, if I approach the limit value, what I get this is equal to 2, sir. So the RHL value over here is coming as 2, sir. What if I approach the same 2 from this side, which is called as LHL, Please check. If I go from here, this value will be what? Always 1. So the LHL value will be always what? 1. And how do we get 1? 2 minus 1. How do we get 1? 2 minus 1. So basically, for any given function of greatest integer nature, the limit value of the RHL remains same as the integer a, so here a, and if you go left hand limit value, this is for the right hand limit value, the left hand limit value becomes a minus 1. Here the a value was 2, so RHL remain as 2, and the LHL value was 2 minus 1. Okay, so if I talk about this, let's say when x tends to 5, the LHL value will be what, sir? 5 minus 1. and RHL value will be what, sir? 5. This is 4 and this is 5. Clearly in all these cases the left hand limit and right hand limit is separate. They are separate. So of course you can say that they are not equal, so the limit does not exist. So for any great integer function, for any greatest integer function, one second, when x tends to an integer z, this is what does not exist. At the integral value only, whether it is 1, minus 1, minus 2, whatever it is, at the integral value the limit does not exist. Moving on. Some limits of trigonometric function. So I have mentioned the first two already. Sin x by x is 1, cos x, tan x by x is also 1. What about this, sir? Same, no? Because I can rewrite this as, remember, limit of 1 upon sin x by x, where x tends to 0, and this can be written again 1 upon limit of sin x by x, x tends to 0, and this is what? This value is 1, so 1 by 1 is 1. Please check. Clear or not? Yes. If you have sin px by p x, answer is again 1, p should be a constant. Here if you have tan px by px, again it is going to be 1 only. If you have x sine of 1 by x, why it is 0, sir? Because sine by 1 by x, when x is 0, beta, when x is 0, what about 1 by x? Infinity. Look at sine function. It will keep going over here for a very large value, plus infinity. What happens to this value? That value at plus infinity will be what? Between minus 1 and 1 only. Because sine function is always what? Between minus 1 and 1 only. Sine functions range always between minus 1 and 1. So whatever value you put for x, the sine 1 by x will be what? A constant number between minus 1 and 1. Agreed? In that case, this will be what? 0 into some number. 0 into some number will become 0 only. It will be what? 0 into some number becomes 0 only. Clear? 1 minus cos px by x square becomes p square by 2. How we solve it? We write 1 minus cos x formula as 2 sin square x by 2. This is what? 2 sin square px by 2, and here also you take x square as what is this? P square x square by 4, so right here 4 also, and here multiply with p square also. Okay, you can check. This value will give me 1, and the remaining gives me p square upon 2. Please simplify this. Okay, yeah. Here this value becomes n square minus m square if you have cos mx minus cos nx by x square. Okay, sandwich theorem. This is very simple. Okay, sometimes they asked, but it's good to know. Something additional actually is not very much relevant for us, but additional information and easy information. So if I write domain of fx as a, for b, gx is b and c. So abc is the domain, sir. Then for all x belonging to the intersection of abc, for all x belonging to intersection of abc, if you have a point in x such that limit of fx and limit of hx is equal at the same point a and a, then even for gx also it will be same. So basically if you look at the graph, at a point this is, sir, f, g and h. At a given point a, if f and h is same, then g will also be same. It's called a sandwiched part. Okay, sandwich between f and g. Okay, provided f is less than g and g is less than h. Okay, in the knowledge hub today, please check some standard limits. Keeps very useful to us. 1 by x, this is very useful in the question solving. One of the PYQ is based upon this. 1 by x when x tends to 0 from positive side is plus infinity, and 0 from negative side is what? Minus infinity. Okay, because from negative side, if you go to 0 beta, from this side any value you take will be what? Negative in nature. No, it will be negative in nature, and very small also. Think, no, minus 0.00000000000000001 somewhere here. If you take 1 above this, because they're saying what? 1 upon x, this value is going to be what? Minus, and this value is infinity, so minus infinity. Again, this is not a calculation, this is wrong. I cannot write a number before 0. Okay, I'm just trying to explain you the concept. This is not wrong, this is not right. Okay, alright guys, if somebody can write a number right before infinity, it will become a revolution in mathematics. Getting it? It's not defined. Okay, if you have limit 1 by x by this, of course, think about it. No, if I go to 1 by x, this is my RHL, this is my LHL. Are they equal, sir? They are not equal. That's why it is not defined. Same for 1 by x square also. Okay. Sin 1 by x, what is all these values are? Of course. So these are some standard limits that you have to remember. Okay, that it is not equal to, or it is equal to 0, or infinity, or does not exist. Getting it? This case is 0 if you have this condition true. Okay. Sin x by 1 minus 1 by x is also limit not existing in nature. Please check. Okay, derivatives now. So derivatives, this is on first principle, but of course this is just for definition purpose, understanding purpose. In question we don't use this much because we can just have to go and do the questions faster. The first principle derivative is given by this: f dash of x is equals to f of x plus h minus f of x upon h. Okay, means right after, this is basically condition for what? The RHL actually. If I write x minus h upon minus h over here, if I write here x minus h upon minus f of x upon minus h, it becomes, this is 0 plus right now, it goes and becomes 0 minus. Getting it? Okay, sir. Alright. Now some conditions. So I'll not give much time to this because all of you who are writing CET knows this very well. Okay. What is this, sir? Sum law of derivative. Of course, you have two functions given. You can differentiate individually and then add. Product difference law also same as sum law. Multiplication, if you multiplied with this, you can just keep the multiplication constant outside and then differentiate and later multiply. See here, the C constant is kept outside. Next, product law. Derivative of product of two function is the addition of derivative of first. Basically, if you have two functions given over here, you're going to differentiate keeping f as it is, differentiate g, and keeping g as it is, differentiate f. Differentiate f. And of course, do not forget, the order is not important over here in the product law. In the quotient law, it's important. You always differentiate the function in numerator first. Can you check this out? F is over here, derivative of f is there into the g function, minus differentiate the denominator then and f as it is. As I mentioned again, numerator function you're going to differentiate first and keep the denominator as it is, minus differentiate the denominator, keep the numerator as it is, divide by the denominator function the whole square. I know you all know this, so I will not spend much time over here. Some important formulas. So derivative formulas all of you anyway know, but still some of them very easy ones. I'll recall it if you know it very well, otherwise you can skip through this part. So if you have a function y equal to ax power n, okay, y1 or y dash or dy by dx is same thing, by the way guys. This or y dash all is same, will be given by a times of n times of x power n minus 1, right? So the constant is kept outside to differentiate this polynomial function. Sin x derivative we all know is cos x, sir. This, excuse me, cos x, sir. If I go with the cos x, we have this as minus sin x. Okay, we have tan x as secant square x, and we have secant x as, what is this, secant x and tan x. If you go and check for cot x, this is what derivative is given as minus cosecant square x, and for cot x into cosec x, derivative is, sorry, what I'm saying, my bad guys, for derivative of cosec x is what, minus cosec x into cot x. So I hope this is clear. Some simple formulas. My recommendation, you can use NCERT for this. Okay, very simple results. Not much is there. A derivative of the exponential function, if you have a power x, it becomes a power x ln a log of a with the base e. If you have natural exponential function e power x, whenever e is involved, that is called as natural exponential function. Then it becomes what? E power x only. This also is the same thing. If the base is e, it becomes 1 by x. If the base is not e, something else is there, you write 1 by x ln a. Okay, you write 1 by x. This is what? You should all know this. This is log of a with the base e is called as ln a. Natural log. What does this means? Natural log. Natural log, sir. Okay. And with the base a is simply normal. With the base 10 is simply normal log. Some more results. Limit of e power x minus 1 upon x is given as, when x tends to 0, 1, and same goes with log also, 1 plus x upon x. Please remember the formulas, guys. Okay. Yeah. You're all asking me for the formulas, but in the notes I've mentioned already all of them. But still, I'll put it together and give it to you. Now, question on this. So we are supposed to say that find the value of a and b so that the limit exists. Limit exists means what, sir? At the point minus 2 and 2 both. If I talk about the point, let's say 2, okay, the point 2, we have this understanding LHL should be equal to what, sir? RHL. Okay, LHL, check here, at 2 will come from here, sir. I will throw 2 before it, no? So 2a plus b. What about RHL, sir? We'll put it over here, 2 square by 2. So 4 by 2, that's 2. So my first equation has formed now. 2a plus b equal to 2 is equation number 1. If I talk about RHL now, this was, by the way, guys, LHL. Sorry, my bad. That was both, no? Excuse me. This was both, right? My bad. Yeah. I've taken over here. This is LHL, this is RHL. I'll go to the second point now. Second point is given as minus 2. So at x equals to minus 2. So if I go with again same approach, LHL and RHL should be equal. Right? Should be equal. So let's write LHL now. We're gonna go from here for the LHL before. So 3 minus 2 square. Okay. And from the right side we're gonna get what? Minus 2a plus b. It becomes 3 minus, how much is this? 4. So I'm getting here minus a1 equals to minus 2a plus b. Equation number 2 we have now. We have our equation 1 and equation 2. Let's add them. Let's add equation 1 and 2. So 2 minus 1, if you add the constant, it becomes 1 only. And minus 2a plus 2a becomes 0. And this becomes 2b. So value of b is coming as, sir, 1 by 2. Value is coming as 1 by 2. B value. Only one case is present like that. Because somebody will think, sir, what about this 1 by 2? No, that's wrong. Okay. A and B they're asking. If you want, you can solve the other one also. Let's try. Not a problem. Put here 1 by 2. So you get here 2a equals to 2 minus 1 by 2. By moving this b on this side, how much is this, sir? 4 minus 1, 3 by 2. Then bring this 2 over here. We'll get the value as 3 by 4. So option C is correct only. Option C is correct only. Clear now? Moving on. Whenever you see this kind of question, you use the approach of L'Hopital. What is this? L'Hopital rule. Excuse me. L'Hopital's rule. Okay, so what is the LH rule, or basically we use always as LH rule. What we use in LH rule? Tell me. Differentiate the given function under the limit without changing the limit. You'll have the same condition basically. That's why I mentioned without changing. So we're gonna keep limit as it is, x tends to pi by 4, and differentiate the numerator individually. Tan cube becomes beta 3 tan square. Derivative of tan cube is 3 tan square. How, sir? Polynomial derivative. X power 3 is 3x square. Now differentiate tan with chain rule. You'll get this as tan becomes secant square x minus secant square x. For cos you'll have minus sine x plus pi by 4. For the second term in numerator, we don't apply chain rule because you don't have to. Derivative of x is 1. Okay. Put the value. 3 tan of 1. So 1 square basically. So it will remain 1 only. Secant of pi by 4 is root 2 actually. So root 2 square. Over here also root 2 square is going to be what? 2 only. Over here what we're going to have? Sine of pi by 4 plus pi by 4, that's 45 plus 45, so 90. Check here, 3 into 2 minus 2 upon minus 1. How come, sir? 3 into 2 minus 2 upon sine 90 is 1, so minus 1. 6 minus 2 is 4. Answer becomes minus 4. Option is B. Clear? So this is a theory class only, but some practice is also required. Find the derivative of these functions. Very simple. Go about it. Polynomial root 2. Derivative of x is 1, sir. Here 2 as it is. Derivative of root x will be what, sir? 1 by 2 root x. And what about this? We'll have minus 1 by 2 and x power 3 by 2. Correct now? How can I say that, sir? Because 1 by root x is nothing but x power minus 1 by 2. Differentiate this with the help of derivative of polynomial function. So the constant minus 1 by 2 will come in front. X power minus 1 by 2 minus 1. That's minus 1 by 2. X power minus 3 by 2. So minus 1 by 2 x power 3 by 2. X power 3 by 2. I wrote the same thing, you can see over here. So this 2 and 2 cancels. We have root 2 over here upon root x we have, and we have plus 1 by 2. X power 3 by 2 is what? Simply x root x. You can see root x is common, guys. Root x is common. So let's do that. Root 2 plus 1 upon root x is common. 1 plus 1 by 2x. I hope this is clear. 1 plus 1 by 2x. Option is D. Yeah? Correct. Okay. This is the end of your chapter, limits, in the theory or one shot of completing all the syllabus portions, including some practice of questions also. I hope this is clear. Okay. That's the end of your chapter, by the way. Option is D for this question. That's all.